Hi, in this video I'm going to show you how you work out the answer to question 6 on the THS practice paper 1. This has been designed for core 1 for AQA, but it's suitable for other exam boards. As ever, get in touch with me on Twitter if you want any further information at Mr_G_Walton. Okay, so question 6 is a big question. It's all about circles. It says, a circle with centre A has an equation x squared plus y squared minus 8x plus 6y equals 11. Part A, find the centre and radius of the circle A. So this is all about completing the square. We know that we are looking for something in the form x minus A all squared plus y minus B all squared equal to r squared, where a and b, a comma b is the coordinates of the centre and r is the radius. So what we're going to try and do is get it looking like this. First thing I'm going to do is just rearrange our circle a little bit just to get my x's together and my y's together. I find it a little bit easier to do it that way and make less mistakes. So first of all I'm going to do that. So I've got x squared minus 8x and I've got plus y squared plus 6y equals 11. Now I'm going to complete the square on the first two terms. So on this part here I'm going to complete the square. I'm going to complete the square separately here, and I'm going to finish off collecting together my terms. So if we complete the square on the first two terms, I've got x minus 4 all squared minus 16. That's the first bit done. Now I'm going to do the next bit. I'm just going to do it in a different colour so you can see the difference, and we'll do y plus 3 all squared minus 9, and this equals 11. So now I need to collect together all of my values. So minus 16 minus 9 is minus 25. Add 25 to both sides gives me 36 on the other side. So I've now got x minus 4 all squared plus y plus 3 all squared equals 36. Now what we were aiming for was something in this form. X minus a plus y minus b, each of these terms being squared, is the radius squared. So in order to work out the centre of my circle, we need to look at these terms here. This was minus 4, so we need to look at this and say, okay, this is going to have to be 4 here. So my x coordinate of the centre is going to be 4, and my y coordinate, well, I want it in the form minus b would have been b. Here we've got positive, so minus b would have been b. Here I've got positive 3, so this is going to have to be negative 3 here for my centre. And the radius, well, we have to be very careful again, not just to write down the value we've got here. Remember, this is r squared, so it's the square root of this. Now typically when we square root values, we could say you've got a positive or a negative value, but in this case we can't have a negative radius, so my radius and r is just going to be 6. Okay, so we've got a centre 4 minus 3 and r is 6. Have I finished the question 6a? Find the centre and radius of the circle A. Yes, I have. Okay, so I'm happy I've done that bit. 2 marks. Not too bad. Let's move on to part B. So part B says the point B has coordinates 0, 2. Find the equation of the line AB, giving your answer in the form given there. So let's just remember what we'd found so far. We'd found that the centre A had the coordinates 4 minus 3. We also knew that the radius r was 6. Okay, let's see then. So it says the point B has coordinates 0, 2. Find the equation of the line AB. Okay, so we're finding an equation of a line. This is just bog standard coordinate geometry now. So we've got 2 points, 0, 2, and we've got 4 minus 3. So I'm going to draw myself a little picture. I find it easier to draw to work out what's going on if I've got a picture to draw. So just over here, let's do that. So here's some axes. And let's just draw roughly something. So we've got 0, 2, which is going to be somewhere up here. And our radius was 4 minus 3, so that was down here somewhere. Okay, so we're looking to find an equation of the line that looks something like this. Now by drawing a little picture, I can already see that the gradient's negative. So before I do anything else, I can see that the gradient's negative. Let's think about what values we've got going on here. Well, this point down here, it was 4 along minus 3 down. So this is 4 here, minus 3 along here, and 2 up there. So we've gone from 0 to 4 along here, and we've gone from minus 3 up to 2 here, which has gone up 5. And so the gradient of this line is 5 over 4. Now remembering it's in a negative direction, so we've come down here, so minus 5 over 4. We've got m equals minus 5 over 4. And of course you can always use the m equals change in y over the change in x formula if you prefer. I don't really mind whichever way, either pictorially or algebraically, whichever way is going to get you the marks. Okay, so we know this. Now we can use our y minus y1 formula. So y minus y1 equals mx minus x1. We can use either of the coordinates. I'm going to go with this coordinate for b, simply because it's easy. I've got a 0 in there, so it just means there's less things going on. So if we put these numbers in, we've got y minus 2 equals minus 5 over 4 x minus nothing. Okay, now at this point I'm just going to see what it says. It wants it in the form px plus qy plus r equals 0. So I don't want, I want everything on the left hand side of my equal sign. So I'm going to multiply everything up first by 4. That's going to get me 4y minus 8 equals minus 5x. Okay, I've expanded this part out in one go. I've said that I've got minus 5 left on here, and x minus nothing is just x, so minus 5x. I've not done anything else there. Now I want to make sure that I bring everything across to the left hand side, which is going to give me 5x plus 4y minus 8 equals 0. And now I've got it in the right form as well. It wanted it in this form here. I'm not too worried that this says plus r and I've got a minus. All it means is that r is minus 8. Okay, so we don't need to worry too much about that. This is looking perfectly fine. I'll just tidy up my work here just a little bit. Okay, right, so we've done part B as well. Let's move on to part C then. Verify that the point B lies outside the circle. And again, this question has no picture drawn for me at all, so I'm just going to draw again a very quick sketch of what's going on here. My circle had centre at 4 minus 3, which I'm going to say is down here. So we've got something that's going to look a bit like this. Just do that bit again. I made a mess of that. Don't worry if it's not perfectly accurate, but try and get it something looking fairly similar. Okay, so 4 along minus 3 down is going to be here, and it had a radius of 6, so it's going to look something like this. Okay, it doesn't have to be perfect, but just something like this. And we're trying to show that 0, 2 is outside the circle, so we're imagining that it's going to be somewhere up here. In order to show that that point is there, we're going to look at the length of the line between here and here. So this is A to B. And what we want it to be is bigger than the radius. So if the length of the line AB is bigger than 6, then it lies outside the circle. So let's just go ahead and work out the length of the line AB then. Again, you can use Pythagoras Theorem for this. So let's think about what we've got here. We're looking for this length. A, remember, was 4 along. This was minus 3 down here. And it goes up to 2. So we've gone 5 units up this way. So what we've got is that the length AB equals the square root of 4 squared plus 5 squared. Okay, which is the square root of 16 plus 25. That's going to give me 41, which is root 41. Well, root 41 is definitely bigger than root 36. So we can say that root 41 is greater than root 36. Therefore, B lies outside the circle. And we can see that quite clearly from our picture too, that if this line up here was root 41 and this length here was root 36, then it must be that this line is longer and therefore the point must be outside the circle. Okay, let's have a look at the next part then. So far we've done A, we've done B, we've verified that the point lies outside the circle. Now we're looking at part D. And so if we're looking at part D, it says the circle crosses the x-axis at the points C and D. Find the length of the chord CD. So again, we've got this situation where we've got a circle and it's crossing over. Here's the centre somewhere down here. It's going to cross over something like this, and we're going to try and find what this point and what this point is here, so we can work out the length between here and here. Now, how are we going to work out what the coordinates are where the circle crosses the x-axis? Well, I'm hoping that you know that the x-axis is also known as y equals 0. So the x-axis is also known as y equals 0. That means we can substitute 0 in to our equation of a circle and see if we can work out what the coordinates are that we've got left. So if I substitute 0 in for my y's up here, then I end up with this. I've got x squared minus 8x equals 11. Okay. All my y's have disappeared. I've substituted 0 and my y's have gone. So I've just now got something in terms of x. It looks like a quadratic, which is fine. That means we should be able to work out what these numbers are. So let's put it into the form that we would be able to then factorise. So x squared minus 8x minus 11 equals 0. Right, at this point then, we'd be looking at this number, saying what numbers multiply together to make 11, at minus 11, and add together to make minus 8. Well, minus 11 is prime. The only numbers that are going to multiply together to make this are 1 and minus 11, or minus 1 and positive 11. Neither of those have a difference of minus 8. So we're going to have to do something else. I think I'm tempted to complete the square on it. So let's do that. I'm going to complete the square. I'm just going to use this form here, basically because it's already kind of laid out for me in a nice way. I've already written it down. So let's go with x minus 4 all squared. I need to take 16 away. Equals 11. Bring my 16 across, so add 16 to both sides. I've now got x minus 4 all squared equals 27. Square root both sides. X minus 4 equals plus and minus root 27, and add 4 to both sides. So x equals 4 plus root 27 and 4 minus root 27. Right, okay. So let's think about which of these is going to be which point then. I think that this point over here is going to be the 4 plus root 27. It's a positive value. So 4 plus root 27 is going to be this one. And this one down here is the 4 minus root 27. that still hasn't worked out a line length. I've just got 2 coordinates. Now, it makes it a little bit harder because these are in surd form. So let's just see if we can work out what would have happened. Let's say if this point here was, let's say, 10, and this point down here was in fact 2 at minus 2, how would we work out the length between here and here? Well, we'd take this point and we would minus this point away from it. 10 minus minus 2 gives us 12. So it would have been 12 if those were the points. Now they're not the points. The points, in fact, are these surds here. But we can use the same process. So how are we going to work it out? Well, what we're going to do is we're going to take this point, which is 4 plus root 27. Root 27, by the way, can we do anything with that? Can we simplify that down a little bit? We might have a look at that in a minute. So let's go ahead and do this. So we've got 4 plus root 27 minus the other coordinate, which is 4 minus root 27. Okay, so we've got that going on. Let's see what we need to do now then. Well, expand my bracket out. 4 plus root 27 minus 4 plus root 27. 4 minus 4 is 0, and now I've just got 2 root 27. So this is the same as 2 root 27. And let's see if I can simplify that down. Well, 27 is the same as 2 times root 9 times root 3. Root 9 is 3, so we've got 2 times 3, which is 6. So the answer here will be 6 root 3. So this is what you're aiming for, 6 root 3. The length of the chord CD is 6 root 3. Right, that took quite a bit of work. The surds that are in there make it a little bit more difficult, but if you're not sure, just pretend like we did here. We said, what if? What if it was 10 and minus 2? How would I have gone about it? Think about the process logically and then have a go with your surds. Okay, so I'm happy that we've now finished D as well. E says, hence or otherwise calculate the area of the triangle ACD. So we'll have a look at that on the next slide. So ACD, that was the triangle from these points here. Now A, down here, was at the centre of the circle. The centre of the circle, we know, will meet this chord at right angles. And so if we are looking at these points, then we've got from the x-axis down here to the centre of the circle, we've got the coordinate here was minus 3. So this has a length of 3. We know the length of between this point and this point here, between these 2 points. We've just worked it out. It was 6 root 3. So this has a length 6 root 3. And we remember that we can work out the area of a triangle because it's a half times by the base times by the height. So I can do a half times 6 root 3 multiplied by the height of the triangle, which I'm drawing it out as here. This is ACD, multiplied by 3. So I've got 3 root 3 multiplied by 3, which gives me 9 root 3. So the area of the triangle ACD is 9 root 3. Okay, again, you would pick up marks on an exam, not both of the marks, but you would pick up some marks by working out the half times the base times the height. If you didn't get 6 root 3, if you used your value between C and D and calculated this part correctly, then you would still pick up 1 mark. You'd miss an accuracy mark, but you'd still pick up a method mark at that point. Okay, so this one, when we were doing equations of circles, there were lots of things going on here, and there was no picture. So one of the things I've said here is draw yourself a picky. Remember, when it gets tricky, draw a picky. I find it much easier to do that. In order for finding the centres, we've completed the square. We've used Pythagoras to work out if any point lies inside or outside or on the circle, looking at line lengths. And again, this is mixing up all kinds of coordinate geometry skills. So you've got various coordinate geometry skills being used with circles. The things that are in particular for circles are some of your circle theorems as well, and just be careful and spot things like a triangle within a circle and so on and so on. As ever, read the question. This is going to be key. If you're not sure on any bit, then see if a little picture might help, and certainly changing some of the numbers might also help you to spot what's going on, like we did before with the line length. As ever, good luck with any exams that you're doing, good luck with the rest of the paper, and if you need anything, get in touch. Cheers, bye.